So this pop quiz related to bonding, empirical formula, and electrolysis. In the first one, the first question, which pair of statements about the diamond and graphite is correct? So when you check the first statement, diamond and graphite are both pure carbon. That is true because like both contain carbon atom. And they are both macromolecules. So that is also correct. The macromolecular structures are there. What about the second statement? The diamond and graphite can both be used as electrode. That's wrong. Why? Because the diamond cannot conduct electricity, so it cannot be used as electrode. Diamond has a covalent bond and graphite has ionic. That's wrong because both have covalent bonds. And the last statement, diamond is hard with a high melting point, where graphite is soft. Till here it is correct, but it does not have a low melting point. It also have a high melting. Both graphite and diamond, because of their macromolecular structure, they both have the high melting. So macromolecular structure, one characteristic of a macromolecular structure, it should have a high melting. So A is the right answer. Sodium nitrite contain nitride ion. Sodium is unstable and sodium nitride is unstable, decompose into its element. What is the equation for decomposition of sodium nitride? First, what should be the formula for sodium nitride? Because sodium is group 1, so it will lose one electron. Like it has one electron in the outer shell, so it will lose one electron. And nitrogen having a valence, nitrogen belongs to group 5, so it has already 5 electron in the outermost shell. So how many electron it need? It need 3 electrons. So how it will get 3 electrons? So there must be 3 sodium or Na nearby. So what should be the formula of sodium nitride? It should be Na3N. Because each sodium loses 1, so 3 sodium will lose 3, and nitrogen needs 3, so it will gain. So the formula for sodium nitride will be Na3N. So which is the correct formula? So this one is Na3N and this is also Na3N. So either B can be an answer or D can be an answer. So the two options are totally wrong, which is A. A is not correct, incorrect, and C is also incorrect. So we are left with B and D. Now, for sodium nitride, because how the metal will exist, if you have a metal, it will exist as an atom. And how the non-metal will exist, except for group 8, the non-metal will exist as a diatomic molecule or a molecule. So when you check this, when they decompose into the element, sodium atom is forming because sodium is a metal, so it will form an atom. And for nitrogen, it is forming into a molecule. So means it should be B. Why not D? Because D is producing both sodium atom and nitrogen. So that's why, because whenever element exists, in element state, metal exists as an atom, as a metallic structure is there, where non-metal exists as a molecule. Is it clear? Question 2. Any doubt in this? Compound X contain carbon, hydrogen, and oxygen only. And what is the empirical formula of a compound? How to work out the empirical formula? You have to follow the steps. The first, you divide by atomic mass. So we have carbon, we have hydrogen, and oxygen. The compound contains 26.7% carbon. It contains 2.2% hydrogen. So remaining will be oxygen. What will the remaining amount? So it will be 71.1 because the total percentage should be 100. Then we divide by atomic mass. Atomic mass of a carbon is 12. Atomic mass of a hydrogen is 1 and atomic mass of oxygen is 16. 26.7 divided by 12. What's the answer? 2.2. This will be 2.2 and this will be 71.1 divided by 16, 4.4. The second step, we divide by the smallest value in the combination, 2.2, 2.2, and 2.2. So when we divide, this will be 1, this will be 1, and this will be 2. So means it has one carbon, it has one hydrogen, to oxygen. The ratio of a carbon, hydrogen, and oxygen is 1, 1, and 2. So it matches with option D. In question 4, cesium fluoride is an ionic compound. Which statement about the cesium fluoride are correct? It conducts electricity when solid. That is wrong. Ionic compound cannot conduct electricity in the solid because ions are not free. Because the ions are not free, so it cannot conduct electricity in solid. It has a high melting point. That's true. Ionic compounds have the high melting point. It is soluble in water. Most of the ionic compounds are soluble in water. It has high volatility. Volatility means like, no, volatility means it can easily be vaporized or it can easily turn into vapor. So volatility and melting point are opposite of each other. So if a substance is having a high melting point, it will have a low volatility. Like it cannot be easily vaporized. So statement 2 and statement 3 are correct. That's why C is the right answer. High, if it will have a high volatility if the boiling point is low or a melting point is low. Usually it is related to the boiling point, low boiling point, high volatility, high boiling point, low volatility. Then this is related to electrolysis. You have to complete the table, writing the product at anode, cathode. So first, you can use a screen annotation to complete this. The first row. Molten sodium chloride. What are the ions present? What are the ions present in molten sodium chloride? Melted sodium chloride. So sodium ion is there and chloride ion. Half equation which we observe at cathode. So what will the half equation for cathode? Yeah, sodium ions are positive ions attracted towards cathode will form a sodium atom. And observation, what will the observation? Whenever a metal is there, so we can write a solid form. At anode, the chloride ion will move. It will form a chlorine atom. When two chloride ions are there, they will form a chlorine molecule and loses two electrons. And whenever like a non-metal is there, so you can mention bubbles or a gas or chlorine, you can mention a specific color of the chlorine, which is yellowish green. So you can mention it is yellowish green gas. If you have molten lead to bromide, same way you have to complete for others. So the ions present, lead to bromide, this Roman number represents the valency of the metal. So there is lead 2 and bromine is group 7 minus 3. Lead is plus 2. It will take 2 electrons, it will form a lead metal. Where bromine, like when two bromide ions are there, they will form a bromine molecule and loses 2 electrons. Aluminium oxide, a molten all, because it's all molten, so aluminium is group 3, it will be plus 3, and oxygen is group 6, so it will be 2 minus or minus 2. So when three aluminium ions will move there, they will take 3 electron and it will form aluminium atom. Where for oxygen, when one oxygen will move there, it will lose 2 electrons. But when two oxide ions move there, it will form an oxygen molecule and loses 4 electrons. For calcium oxide, it contains calcium ion and oxygen ion. So calcium is plus 2. It will take 2 electrons. It will form a calcium atom. And for oxygen, when two oxide ions are there, keep it there. When two oxide ions are there, it will form oxygen gas and 4 electrons as well. Molten iron 3 nitride. So it contains iron 3. The Roman number represents the valency. So it contains iron 3, and nitride means nitrogen is there. So when iron is plus 3, it will take 3 electron, it will form iron atom. And nitride, nitrogen is minus 3, it will form a nitrogen atom by losing 3 electron. If we have 2 nitrogen, they will form a nitrogen gas and loses 6 electrons. And the observation, whenever you have a molten substance, so it is a common observation at the cathode, you will always observe a solid because metal is extracted at the cathode, so you will observe solid. And a common observation at anode, it will be because a non-metal is there, so you can mention bubbles or a gas. But specifically like lead to bromide, it will be a brown gas, oxygen colorless gas, nitrogen also colorless gas. So these are the products which are formed at anode, cathode, and the electrolyte. Any question in this?